Okay, now we're going to take a look at an initial value problem application. Okay, so let's take a look at what we've got. It says in a chemical reaction, the rate at which the amount of a reactant changes with time is proportional to the amount present, such that dy dt equals negative 0.7y when t is measured in hours. If there are 77 grams of reactant present when t equals 0, how many grams will be left after 2 hours? So we're also asked to give our answer to the nearest tenth of a gram. So they've given us an initial value. We're going to solve a differential equation. And then once we've done that, we're going to use that new equation to find the remaining amount after 2 hours. So it's a few parts to this problem. All right. The first thing, of course, is to solve the differential equation, dy dt, find a solution. So we're going to start off with this, and we're going to apply what we know from before, which is a separable differential equation concept. And that is through some cross multiplication, if you will. All right. So what we're going to end up with is, and it's actually not cross multiplication now that I think about it, there is some multiplication involved. We're going to multiply by the dt, but then we're going to divide by the y. So we're going to do that, multiply both sides by dt, but then also divide by y. That's what ends up happening. Okay, so let's take a look. We end up with dy over y equal to negative 0.7 dt. All right, and that's not terribly difficult then to integrate, and we're going to do just that. Okay, the left-hand side here gives us a natural log of the absolute value of y, whereas the right-hand side gives us a very simple power rule, and we end up with negative 0.7 t plus the constant of integration c, and we're going to be looking for that very shortly. Now we're going to solve for y to obtain a solution, and in doing so we're actually going to raise both sides, take the natural base to eliminate the natural log, so that we can end up with a y, an equation, a solution. So y equals e to the negative 0.7 t plus c. So that's our y value. All right, now that I've obtained that, what I'm going to do is I'm going to solve for my constant c by plugging in the initial condition that I was given. And so what I know from the initial condition is that when t equals 0, I have 77 grams present. So what I'm going to do is I'm going to say, okay, then y of 0 will give us e to the negative 0.7 times 0 plus c equals 77. Okay, so then I have 0 right here. That eliminates itself. I end up with e to the power c equals 77. And in order to solve this, I take the natural log of both sides. And that's not too difficult. Okay, so what do I get for my constant of integration c? I get that it is the natural log of 77, and I think we're just going to leave it like that. Okay, we've solved. Okay, now I have obtained my solution, and my function, or my functional solution, is e to the negative 0.7 t plus the natural log of 77. Now if we go back to the question, they asked how many grams would be left after 2 hours. So they are telling us that t equals 2, and they want us to determine how many grams will be left at that point. So what I then need to find is y of 2. And so I'm going to encourage you to use a calculator in order to do this. And when you do that on your calculator, you're going to get something close to 19 grams. Okay? So the answer for this is that 19 grams are remaining. Okay? 19 grams remaining. All right. So really a nice application of separable differential equations, solving a differential equation, and then applying the solution from the differential equation to find, in this case, how much was left after something is decaying, okay, in this chemical reaction. All right. So as always, I hope this video was helpful, and remember, like and subscribe.